Hello everyone. In this video we'll be talking about another tool for the improvement phase, and this is called the design of experiment. Again, this is Dr. Mahmoud Al-Odeh, and here you go. The design of experiment is very powerful tool that we use it to determine the cause and effect of the different relationship between different factors, and this tool will help us to determine the optimal solution. Every process can be considered as a black box, so we need to know exactly how we could do this process. So the black box, no one knows anything about it, so there is some input and output. So imagine that there is an equation, y equal to fx, which means that in order to get the y, there are different parameters, x1, x2, x3, or parameter 1, parameter 2, parameter 3. Once you combine them together, you will get the y. So for example, if we're talking about the most appropriate combination for the cycle time, think about the cycle time. What factors would impact the cycle time? Better equipment, improving worker training, just-in-time process, better vendor management. So if we combine these four factors together, that will impact the cycle time. So the cycle time would be y, that's the result, the output. And for the equation that we have x1, which is the getting better equipment, improve worker skills or training. Number 3, just-in-time process. X4 or factor 4 would be better vendor management. Somebody will come and say, oh, well, let's do something else. Maybe the buffer in between the stations. Yes, absolutely, you're correct. So this is the whole idea of the design of experiment, is to look into different factors that will impact the final result, that will impact the y. So the design of experiment, you play with these factors and see which one has the most impact. Let's go ahead and take about the advantages. Let's take a look into the advantages of the design of experiment. Some of the advantages is you will be able to improve the quality of your service or your product. You will be able, by studying different factors, you will be able to reduce the cycle time. Number 3, you will be able to reduce the defects, which is great. This is addition to you. This is great. We need to look into that. Also, some of the advantages for the design of experiment is to reduce variation. We need to reduce the process variability and variation, which will give you a more stable process, a higher quality, and narrow down values, which will help you to achieve a Six Sigma process. Reduce the cost of poor quality. Increase the rate of investment and financial aspect. Customer satisfaction will go up. And learning more about the process. By studying the factors, you go into deep details of the process, the deep details of the factors, and you better know the process. This is the simple example that I ever seen about the design of experiment. The result is we need to make a cake. Who doesn't love a cake? I love cake. But in order to make a cake, you have to have some factors, some environmental thing that will impact the factor. So you have to have the equipment, the oven. You have to have a raw material, the sugar, the flour, the eggs. Okay. Once we have all this, we'll move on to the different thing that will impact the output, which is the levels, the settings, basically. The settings for the environment, the temperature, the type of pan and the quantity of the sugar, the quantity of the flour, the quantity of the eggs. This all impact. You can't say I'm gonna put 10 eggs for like small cake. Well, you have to have a settings that will help you to get a really good quality of cake. So let's talk about three things. These are the most important things that we deal with design of experiment. These are the concepts that we need you to be familiar with. The factors, these are the variables or the input, the levels, which is the settings for the experiment, and the responses, which is the outcome, the output. Let's take a look into more details. These are really important concepts because when we talk about design of experiments, we use these. The factor. What is the factor? Any variable that may influence a process. Factor is the input. Again, let's take a look into here. These are the input, the oven, the sugar, the flour, the eggs. Next, the level. This is the settings or category that a variable may take. Two or more levels could be chosen in each category. As you see it right here, we have 4 levels. You could choose one. You could choose 1 or 2 for each category. So you say, okay, I'm gonna focus on the oven and maybe the temperature and the amount of eggs. I'm gonna study this and see how that's gonna impact the quality of cake. Trial. It's one trial or one run during the experiment. So just doing the experiment, this is called a trial. Factors are set at different levels for each trial. So you could say, okay, I'm going to change the temperature. I'm going to play with the quantity of the sugar, and the quantity of the flour. That's the trial. It's just doing the experimentals. Response variable, this is the outcome, specific parameter used to decide if the process is improving, helps in determining the type of quality to be collected. Now, also we have to think about the interaction that will happen in between the factors. This is important concept in the design of experiment. This interaction between factors when an experiment is being run. 2 or more factors may interact and influence the response variable. It is important to understand the interaction between factors while doing design of experiment study. One time at a factor. Now let's talk about different settings for the experiments. One factor at a time, which means you only select one factor and you start changing it. And then you see what's the impact of changing only one factor at a time. Level of the first factor is changed while others stay at the same. So the other factors will stay the same. 1 or more trials are run until the best level of the first factor is determined. So you run the first, the second, or more as you need until you determine the best value for the first factor. Once you reach the best value, which maximize the responses variable, which give you the highest quality of the output, then you try the other factors. And this is the simplest experiment and design of experiment, the DOE. Factorial design. Now, there's a different factorial design, allows experimentation on a many different stimulusi. Some examples, 2 factorial design. 2 factors are changed simultaneously, and the impact of the response variable is studied. Factorial or fractional. The fractional factorial experiment. Only some of possible factors and levels are studied simultaneously and at the same time. Full factorial experiment, all the combination of factors and levels are studied at the same time. So think about it. If you have just only 2 factors studied together while the other still constant, this is a 2 factorial design. Fractional factorial design, only some of possible factors, only some of them. This is fraction, just some of them Could be more than 2, 3, 4. Full factorial when you study all of them at the same time, which is the hardest level. So the simple way to do the DOE is the one factor at the time, and then you go with a two factorial design, and then the third level would be the fractional, which means that you have 3 or more, and the full factorial, you combine all the factors together. Before I end this video, I'm just going to talk about Goshi very quickly, the concepts. And Goshi, as you know, he's a Japanese quality scholar, and he came up with the idea of the noise, and the noise should be minimized. Any process has a noise, and these noise should be removed from this noise should be removed from the process to improve the quality of the process. Goshi come up with two different categories or variables: controllable variables and uncontrollable variables. Controllable variables, these can be controlled through the design of experiment. So once you do the design of experiment, these are the variables that you can do and control. Their impact of the process under study is predictable. The Goshi concept helped in determining the settings for the controllable variables, which minimize the variability of the y variable, or ensure that the y variable is always near desired levels. Uncontrollable variables. These variables cannot be collected. You can't measure it. These are uncontrollable, such as the weather, the nature. The Goshi tried to determine if some of these uncontrollable variables could be made controllable. Alternatively, what would be the best settings for controllable variables to minimize effect of uncontrollable variables? Which means that Goshi came up with the idea of the noise. Any process has a noise, and this noise could be controllable variable and uncontrollable variable. Once you know what's the controllable variable, these are the variables that you can predict. However, the uncontrollable, you can't predict them, but what you need to do, you have to minimize the impact of these uncontrollable variables. With that said, I'm going to end up my video right here, and I will be recording another video for the rest of this improvement phase. I'll see you in another video. Stay tuned.